Okay, so how is it going? Did you solve the problems? So I want to finalize this lesson today. So this would be the last session that we want to talk about the cross product of vectors from the geometrical point of view. So let us try to solve that. You help me and we will solve it together. So we have three vectors. We know that none of them are parallel to the other one, and then we know that they don't lie on the same plane. Okay, so we only know these pieces of information regarding these three vectors, and then out of these three vectors we construct three new vectors by these linear combinations. So the first one I add v and w, the second one is this, the third one is this. I am claiming that these constructions, these three new vectors, will not be on the same plane for sure. Okay, how we should prove this? Do you remember? We had a necessary and sufficient condition for three vectors be on the plane. The reason is that, do you remember last time we talked about what is called a mixed product? Yes, if I give you A dot B cross B, we call it the triple product or a mixed product of three vectors. And do you remember what was the geometrical interpretation of this? Yes?
If it's equal to 0, they lie on the same plane.
Yeah, so what was the interpretation of this? Yes, you are answering the first question. Then I'm just reminding you. So what was because A, B, and C are vectors, and definitely you realize that this would be a number at the end. So I'm asking you, what was the interpretation of that particular number? Do you remember?
B cross C is perpendicular to A. So the dot product is 0.
Pardon?
Are you working?
Yes.
Recording?
Yeah.
Okay, yeah.
So, no, I mean that if you calculate this, it becomes a number. For example, you calculate this, it becomes 5, it becomes 7, whatever. What is the geometrical meaning of that 7 or 5 that we get? We had it last time, do you remember? We introduced the notion of a parallel pipette. Do you remember parallel pipette? And that was this one in absolute value. This becomes the volume of that parallel pipette, which is constructed on these three vectors. Yes, do you remember? And that is the reason. If I sit down on this parallel pipette and it becomes degenerate, then the volume becomes 0, and then those three vectors will lie on the same plane. So remember, that's an important thing. So three vectors lie on the same plane if and only if triple product of those three vectors becomes 0. And we also learned that there is cyclic property. Do you remember the cyclic property of this combination? So if I start with A dot B cross C, it doesn't matter if I start from B and dot C cross A, and it doesn't matter if I start from C, but you have to respect the order in which you read it, the cyclic property. So it's sim, after C should come A and then cross B. So in principle, if you have vector A here, vector B here, vector C here, so I go from A to B, from B to C, from C to A. So if I have this way of reading, these combinations will be the same, yes? So A dot B cross C will be the same thing if I start from B and write B dot C cross A, and it would be the same thing if I start from C and write C dot A cross B. So, and that is called the cyclic property of this triple product. Okay, so here if you read the first sentence, this tells you that these three vectors don't lie on the same plane. So this translates itself to this. It means that U dot V cross W is not equal to 0. This is the meaning of the first sentence. And then we want to show that based on this assumption, these three vectors don't lie on the same plane. So what should I do? I need to calculate the triple product of these three new vectors, yes? So I have to construct V plus W dot the cross product of the second one with the third one. Yes, so we have to show that this combination, of course this is also a number because this is a vector cross product is a vector, dot product is a number. We want to show that if this is true that this is not equal to 0. Yes, and I told you that from geometrical point of view, visualizing these three vectors are not that easy. Yes, so this is the benefit of doing things algebraically. So what is your suggestion? I want to simplify this mixed product as much as possible. So where should I start? Where should I start from? Yes?
Yeah, expand.
Yeah, we have to expand this one because here, let us keep it for the time being. V plus W, and then I will start expanding this. So it becomes 2. You know that you have to respect the order when it comes to the cross product. So this becomes 2V cross U. You have to write it in this way, and then you multiply V cross V, and then you write plus 3V cross W. So the order actually is very important. And then I go to the next one. It becomes minus 4W cross U minus 2W cross V and minus 6W cross W. And I will try to simplify this as much as possible. So immediately you realize that this term is the 0 vector because I am multiplying a vector by itself, and I am doing the same thing here. So these are 0 vectors. But can I simplify this more? Can you see it? So let me write it as V plus W dot, dot, and then what do I have here? I have V and U here. I do not have V and U's anywhere, so let me just copy and paste this one. Go and VW. Do I have VW? Yes, here. This is VW, but in a different order. Yes. So if I will interchange this. I would write it positive 2, but I have to swap these two. So it becomes V cross W. Then I have 2 of them here. 3 of them here, so it becomes 5 of them. Yes, 5 V cross W. Yes. Is there anything more? Yes, there is also one term that survives here, and that is that term. So it's minus. If you don't mind, let me write it positive, and I interchange 2 again. Of course, it doesn't matter, but let me write with positive sign everywhere. Okay, I cannot apparently continue this one more. Then what should I do? We have to distribute this one in, yes? So what happens, I would write this one, I have to take it and multiply it here, here and there. So this becomes 2 is floating, it's a number, so I will bring it out, so it becomes V dot V cross U. It becomes another combination of triple product. But then this one multiplied by that one, it becomes 5V dot V cross W. And then this one to the last one, so it becomes 4V dot U cross W. And then I have to start with this one, so it becomes plus 2W dot V cross U. And then the next one is 5W dot V cross W. And finally plus 4 W dot U cross W. Yes? Understandable? Okay. So what is the goal? I know that this triple product is not 0. I want to convince myself that this new triple product is not 0 either. but we haven't succeeded yet. I want to make sure that this long combination is non-zero. But there are some terms that I can immediately get rid of, yes? Which terms? For example, this term, what is the answer to this term?
0.
0. Because V cross U is a vector perpendicular to these two, so it becomes 0 here. This is number 0, so this will go away. This one, for the same reason, will go away. And then, what is left? Okay, here you see again this combination. This will also cancel. This also will cancel. And what is left for me? Only these two. Okay, what can I write? If I ask you to write it simpler, then you know what to do. So how should I write it simpler? So let me clean here. Oops. Okay, so how can I write it simpler? So let me see what is the result. The result is 4V, let me write it here on top, dot U cross V, U cross W, sorry. The other one is, 2 W dot V cross U. Okay, if I ask you to simplify this, then you can use this cyclic property, yes? You can write it in a way. So let me write everything in this form. So let us have U first. If you want to write this one U first, can you just tell me what to write? I want you to write this in a way that U comes first, V goes second, and W goes third. So is it in the correct order in this form right now? No, because if you start reading from U, the next one should be V, it is W. Yes? So what do you think we should do? If I interchange them, it becomes negative here. This becomes V dot, and then it becomes W cross U. At least now it is in the right order, because if I start reading from U, it goes to VW. So that's good. What can I do for the next one? Is it in the right order? Again, no. You see, if I start reading from U, it becomes UW. I expect to have UV. So I will write it minus 2W dot. I will interchange these two, U cross V. Now everything is in right order, okay? So if you start reading it from U, UVW, correct? UVW, correct, okay? But of course they are not exactly the same thing. Now I can use the cyclic property. So what can I do? I want to write it in a way that U comes first. So it becomes minus 4. What should I write? Can you tell me? I should write U first, and then dot, and then cross. What is coming after U now?
V.
V. What is coming after V now? W. Yes? So that is exactly equal to this without any changes in sign. And this one I want to have minus 2. I would write U first, and then I want to have it cross here. So it becomes V, W, because it is in the right order. And if I ask you to simplify this, it becomes minus 6 U dot V cross W. Yes? So finally we were able to simplify this. This is a skill I want you to improve when you're working with vectors. So after calculation, we got this answer, but this is guaranteed not to be 0. Minus 6 is not 0, and this is my assumption that these are not coplanar vectors, so this is not 0, so this is guaranteed not to be 0. Yes, if I give it number 1, because of number 1, this is not equal to 0. Okay, so I want you to learn these kinds of calculations. This is also algebra, but vector algebra. So you are learning new type of algebra. Okay, so what do you think about this problem? So I erased that accidentally. U, V, and W are vectors that are not coplanar. But this time I am asking you to calculate the real number x in a way that if I have these 3 vectors, these 3 vectors are guaranteed to be on the same plane. So what I'm supposed to do? So again, I think you now know what to do, because you want to force 3 vectors to be on the same plane. This happens if and only if the triple product is 0. So it means that I will take these three and form any triple product that I want to. I don't know which one probably is easier. I don't think it matters. Okay, we can put this outside and these two inside, yes? So we want to have this x minus 1. So let me write this, if you want to write it formally. These three vectors are coplanar if and only if the cross product is, the mixed product is 0. The triple product is 0. Dot. The other two. U plus xv cross, and then I have v plus xw. Am I right? So those three vectors, but we need to know where this is needed. We will see why this is needed, this assumption that u, v, and w are supposed to be non-coplanar vectors. We will see why we have to use this fact. But we want to fine-tune x in a way that these three vectors become coplanar. So this becomes coplanar if and only if that condition holds. So then again, I have to start simplification, yes? So let me just keep it like this. X minus 1, v plus w dot, I will do the simplification here. So u cross v, u cross this one, x is floating, so I can write u cross w. You have to respect to the order. And if you don't mind, let us do it in our head. This one multiplied by that one is the 0 vector. But this one times that one becomes x squared plus v dot w. Oh, sorry, x squared v dot w. Is there something that I can simplify more? Apparently not. So then I have to start multiplying once more. So I multiply this by that. And if you don't mind, let us do it in our head. If I multiply this by the first one, what would be the answer? I am dot producting this one by that one. X minus 1 is floating, so you don't need to worry about that. V dot this combination is 0. Is that understandable? So I will not do that. If I go to the next one, I have to write it down. So x will be multiplied by that, and then v dot u cross w. Yes. And then if I take this one to the last one, what will be the answer? 0 again, yes? So don't write it down. And then I will take this one to that one. And then this one by that one for the same reason is 0. This one by that one for the same reason is 0. So that would be the simplification of this long expression. And then, of course, are they in the right order, both of them, if I want to combine them? I start from u. For example, u, v, w is a good order. So let me make it in the same order. So I will interchange them, and I will get a negative sign here. So here, u, v, w. So it doesn't matter if I write it in that way. Understandable? This one that I have written here, according to cyclic property, is exactly this one. And now I can use the cyclic property once more. I can write u first, v second, and w third. And then I have the same thing there. Yes? Oh, by the way, I forgot to write, I should have written 0 all the time, yes? If and only if and only if. So sorry, I have to write 0 because I want to make it 0 intentionally. Yes, that is the correct way of writing, so there is no equality here. Okay, but now I can combine them. There is 1, a factor of 1 here, the factor here is this one. So if I factor this out, it would be 1 from that one minus this one. It becomes minus x squared plus x. Yes, and then I will have u dot v cross w equals to 0. But this happens if and only if this is 0. Why? This matters. U, V, and W are not lying on the same plane, so it is guaranteed that the triple product of these three vectors is not equal to 0. On the other hand, I want to make the combination equal to 0. So this is if and only if minus x squared plus x plus 1 equals to 0. Since U dot V cross W is not 0. And then you solve this equation. So this becomes minus 1 plus or minus delta here is 5 divided by minus 2. So it is related to the golden ratio. Yes, do you remember? We had it in Math 5. So anyway, if I choose these two numbers and put them here, I will get three vectors that are definitely lying on the same plane. Is that clear? Okay. And now let us go to the next and that problem. So what is this one? Could you solve that one? The volume of the tetrahedron. It's like a pyramid with faces to be triangles, yes? So the volume of the tetrahedron built on vectors u, v, and w is 5 volume units. Determine the exact value of this expression. So do you remember what was the formula for the volume of the tetrahedron? It's a pyramid, so the formula is the area of the base multiplied by the height divided by 3. But if you remember, I found another formula for you using the triple product. The difference was that the coefficient, instead of being 1/3, is 1/6. If you refer to your notes, you will see it there. So let me clean this one. So the volume of the tetrahedron, so let me write this, is 1/3 the area of the base multiplied by the height. This we know from Math 1C, but then I told you that if you see the proof, it turns out that this becomes 1/6 by the cross product by the triple product of the vectors passing through the same point. Yes, on the tetrahedron. So of course, because we are working with vectors here, it is clear that this is probably more useful for us. So this is telling you that the volume of the tetrahedron built on the vectors u, v, and w is 5 volume units. So what does it mean? It means that the volume is 5. This is equal to 1/6 u dot v cross w. So what I get is that absolute value of u dot v cross w is equal to 30. This I get. But unfortunately, this absolute value doesn't have this property. I cannot write the absolute value of this is equal to the absolute value of the first one plus absolute value of the second one. We don't have that, yes? Absolute value of x plus y is not equal. By the way, it is always less than or equal absolute value of x plus absolute value. So there is no guarantee that this is equal to them. So even though this is apparently useful for my purpose here, but we should find another way. Okay? So what do you think I should do now? What should I do now? Yeah, I can clean this one. I'm just trying to calculate this expression. So let me write here. My question mark is absolute value of u dot v cross w, and then plus w dot v cross 3u. Okay, what should I do now?
Yes? Take out the 3 from the right one.
So we can take the 3 from, if you don't mind, let me write 3 here.
And then use the cyclical format to get you that, but then you have to change them.
Okay, so I have to use the cyclic property, but is it in the right order now?
No.
As this one? Not the right order. I mean the order here and the order here are different, because if you start reading it becomes UVW, if you start reading from here it becomes UWV. So you need to fix both of them in a way that they match. But this one, I have this here, so let me change this one. So yes, you are right. So this becomes U dot V cross W, and then I interchange them, it becomes negative. But at least now they are in the same order. They are different slightly, but you know that I can use the cyclic property now. In cyclic property, I don't need to be worried about the signs at all. I can just write it as U dot V cross W. But the point is that whatever this number is, that is the same number minus 3 times. So this one and that one becomes minus 2 times, yes? So it becomes absolute value of minus 2 U dot V cross W. But even though this formula is not correct for addition and subtraction, this formula is correct for multiplication and division. Yes, that is correct. So what can I write? I can write this becomes absolute value of minus 2 multiplied by absolute value of U dot V cross W. But absolute value is 2. This absolute value I got 30. So the answer is just simply 60. Yes? Is that understandable? Okay. What about the last one? That is also very simple, but you need to get used to this way of thinking with vectors. If I ask you, give it a name, what is the left-hand side? Is it a cross product? Is it a dot product? What is it? What is the left-hand side? You can call it. So for example, if I ask you what is this, you will say that this is the cross product. If I say what is this, you will say it's a dot product. And if I ask you what is this, you can also say this the same thing, dot product, cross product. But if you look that one as one piece, then you can call it what? A triple product. Yes, it's a triple product. The first vector is V. The second vector is U. The third vector is V cross U. You can view it as a triple product again. So what do you think I can do now? Might be we can do a lot of things, but at least one thing should be clear for you. So what should I do now?
Use the cyclic property.
Cyclic property. Which one? So you see, so if I want to start from the left-hand side and use the cyclic property, the way that I am reading it shouldn't change. V comes first, U comes second, V cross W, V cross U comes third. Now the way I have to read it should be V cross U, and then dot, V goes in, it becomes V cross U. Yes? As simple as that. You see, it's not very clear, but hopefully you realize that's exactly the cyclic property. You see, this is playing the role of your W here. This is your first component, this is your second component, this is your third component. What is cyclic property? Cyclic property tells you this. Is equal to that is the cyclic property, isn't it? Right? And then I have written it exactly here. This is 1, 2, 3, 1, 2, 3. But then I can write 3 first, 1 second, 2 third. 3 is this guy, dot. 1 is this guy, V, and then 2 is U. That's it. Understandable or not? Dylan, are you confused or no? Is it happy? So do you agree that this is cyclic property? Yeah. Just take this one to be 1, 2, and this one 3. And then put, instead of 3, put this one, it becomes this. And then put dot, it's dot, and then put 1, which is V,
Oh yeah.
and then cross product. Yes. But now what is the answer to this immediately?
It's squared.
It's squared of the same vector, because if what is the rule? If I take any vector, dot product it with the same vector, it becomes the norm of that vector squared. Yes, and that's exactly the same thing. I have the same vector multiplied by the dot product. So that is exactly very, very simple. Yes. And that's equal to the right answer. Weird. Yes? So, okay, I have a little bit of time. I want to finalize this lesson. And that is called the back cab rule. And the reason is that it's called back cab is because people want to memorize it. It's a little bit complicated. Okay. So let me write theorem. Even though I want to use always u and v for vectors, but here I start using a, b, and c as vectors. For any three vectors, any vectors a, b, and c. Okay, we want to calculate. There is no name for it. It's not a triple product or whatever. I want to write a formula, a nice formula for this combination. So first of all, I want you to understand that this makes sense. Yes, because three vectors. I have b cross c, do you remember? It becomes a vector, and I have another vector, so the answer will be definitely a vector. But I want to see, can I write it something like? But I want to test your understanding before writing the answer there. I am claiming that this vector eventually will lie on the plane of A and B, or A and C, or B and C. And I want you to visualize it in your head and guess which one. Yes? So what I'm saying is that I guarantee you this will be of this form. A number, so let me call it alpha, vector B, plus beta, vector C, or alpha, vector A, plus beta, vector C, or alpha vector A plus beta vector B. So if I ask you, if I give you two vectors, so I told you that always two vectors are coplanar. Even if they are in this situation, I parallel transport them, so they are coplanar. And if I multiply one vector by any number, I will change the length, but I will not change the direction. And if I do the same thing, it will happen for this. If I add a multiple of this with the multiple of this, it will remain on the same plane. Is that understandable? So that's very important. If I give you two vectors, which are non-parallel vectors, but non-zero, they always construct a plane for me. But if I make this combination, I will not go out of that plane. I will remain in the same plane. Yes? Now my question is that, do you think the answer to this would be something like this, or something like this, or something like this, if I guarantee that one of them is correct? If one of them is definitely correct, which one do you visualize? How do you visualize? You should visualize it in a way. You have three vectors, this one, and probably another vector coming out. So let me call the black one A, the blue one B, the red one C. And then I want to determine about this vector. Okay, A, so B is this one, C is this one. I cross product them, it becomes a vector perpendicular to them in this direction. And I will take that vector and take this vector and cross product it with that one. Yeah, I want to visualize it a little bit. Yes? Thank you. Did you submit here as well? Yes. but you have to wait. I cannot move the camera now. Okay, just 5 minutes, thank you. Yes?
Alpha B plus beta C.
Yes, that is the correct one. So this would be the correct. Why is that, by the way? If I ask you, I don't know, how did you start visualizing it? Yes, how did you do that? Yes?
The cross product has to be perpendicular to the first B cross product C.
Yes?
So that has to, at the end of the day, be perpendicular to the plane of B and C.
Yeah, exactly. That's the best way to visualize that. Otherwise you get confused. I actually wanted to make you confused by thinking in that way, okay? But if I say, if B cross C, what is that? If I say, where is B cross C? So just think about B and C. B and C. B cross C in this way is just perpendicular to this plane. Okay, now forget about this. This is a vector. I am multiplying, I am cross-producting with another vector. So the outcome would be a vector which is perpendicular to A and a perpendicular to B cross C. Yes? If this is going to be perpendicular to B cross C, it goes back again to the same plane. So it is not really confusing. You see, B cross C is this vector. And if I ask you, so let me ask you this question. Do you agree that this vector, if I write this, do you buy it or not? This vector is perpendicular to B cross C. Yes? That's the definition, yes? Box, cross, I don't know, circle is perpendicular to the box. It's perpendicular to the circle, yes? So if I ask you, do you agree with this one? You should say yes. So this vector, whatever it is perpendicular to B cross C. Yes? So you shouldn't get confused. This is B, this is C. B cross C will be this vector. This vector should be perpendicular to this new vector. It goes back to the same plane. Yes? So it should be a combination of B and C. Definitely. But which combination? So here, this is definitely a combination. But the combination is the back cap rule. That is for memorizing A, B, C. You call it back cap. You need to, this is the way that people write it, because to memorize it. Back cap, yes. And there is a slight deviation in writing, because you know that what is this one? This is a number. Usually you write numbers on the left, but then it becomes accurate. So memorizing it is hard. People put it on the right to memorize it easily. So it is back cap. So it means that this is playing the role of your alpha, and this is playing the role of your, this one with the negative sign is playing the role of your beta. Okay, so now the formula that we have, if we have three vectors, A, cross B cross C, so we learned that we can write it as a back cap B minus cap. Okay. So as I told you, we will talk about the proof of this later, because it will teach you a lot of tricks. It was not that easy to discover. But let me tell you something. We learned that this would be in the plane of B and C. And then this means that A cross B cross C is a number multiplied by B plus another number multiplied by C. Is that understandable for everyone? This is also, by the way, important. So you have this in physics, but so for example, if I give you two vectors that are not parallel on the whiteboard exactly, so let me call one of them B, the other one vector C. Yes? I hope that you agree with me. I want you to understand it, because probably you have used this in physics somehow. But if you have a vector again on the whiteboard, definitely that vector can be written as a linear combination of B and C. Yes. Is that understandable for you or not? How? Can you convince me that if I give you any vector on the whiteboard plane, for example, that vector is definitely a number multiplied by B plus a number multiplied by C. Why is that? For example, let me draw another vector here for you. Wherever that vector is on this whiteboard, I can parallel transport it and draw it, for example, from here. How can you convince me, let me call this vector W. How you can convince me that this W, I only need these two vectors and two specific numbers, so that if I multiply an appropriate number here, an appropriate number here, and add them, it becomes this orange vector. So how can you convince myself after studying all vectors all the time? So this is not three-dimensional. Every vector is on the whiteboard plane. I want you to convince me that this vector can be written as a linear combination of these two vectors. Linear combination means a number multiplied by one of them, another probably number multiplied by the other, and then add them. Why is that? So you have used this in physics probably. Do you remember when you want to solve inclined surfaces, and then you have, for example, a box on it, and this is the gravity force, which is perpendicular to the horizontal, and then you decompose it into two components, yes? So you would say that, okay, this vector can be decomposed here and here, yes? And then you solve the problem. And that's exactly the same idea that you are using, but of course in mathematics, we want to solve the problem for every situation, not just this simple. Okay, so the idea is exactly the same as before. So what I'm supposed to do, do you have any ideas? So let me clean, might be I need to draw some pictures here. So how you can convince yourself of that? Any ideas? So what you do, you draw a line from the tip of this vector, parallel to this one, and another one parallel to this one. Yes. So might be, I intentionally drew it outside, might be you're a little bit confused, so let me write it here. So if assume that your W vector is here, yes? So what you do, you take this one, continue this, and draw a line parallel to this one, yes? And draw another line parallel to this one, yes? I hope that you agree that these two vectors, if added, it gives me W, because that's a parallelogram law. And this vector, whatever it is, it's a multiple of this vector because it lies on it. And this vector, whatever it is, it's a multiple of that. So this vector can be decomposed as a multiple of this plus a multiple of that. It's always the case. I intentionally drew this outside a little bit because that would be a little bit counterintuitive. But this method should work, okay? Hopefully it will work. So what should I do? I took the tip of this vector and I drew parallel lines to these two. Yes. So what I do, let me see if the idea will work, by the way. So I will draw a line parallel to C for the time being. This is the line that I draw from here parallel to C. I draw another line parallel to, but before that I want to find the intersection point, unfortunately. Yes, it will work. This, I should continue up to here, and then I find the intersection point. This is one of my vectors that is going to play the role. And then here, I will draw another line here, parallel to this one, but this time I will continue it in a way that it will intersect this one. But if I continue this way, it will not work, so I have to continue in that way. Yes? And now, I hope that you agree with me, this picture here, this quadrilateral, is a parallelogram, yes? Because this line is parallel to that line, and this line is also parallel to this line. So this one is a parallelogram. And if I give you this vector, for example, m, if I call this one vector n, I hope that you agree with me that if I add m to n, it becomes vector w. Okay? But if I ask you what is m, because m lies on this vector b, it's a multiple of b. Yes? In this case, this multiple is negative. Yes? And n, whatever it is, it lies on c, so it's a multiple of c. So this means that any vector can be decomposed as a multiple of b plus a multiple of c. Okay, so if you have a vector in that plane. Okay, so if I go back to the back-cap rule, yes, actually we convinced ourselves that that vector, it's very simple, that vector A cross B cross C, so we know that A cross B cross C should be perpendicular to B cross C, of course, and it should be also perpendicular to the vector A. Yes? And is that enough to conclude that this vector lies on the plane of B and C? Yes, yes, because if I have two vectors B and C, and then if I cross product B and C, it would be this vector. And if I want to have a vector which is perpendicular to this, it should go back to the same plane. Is that understandable? Is this geometry understandable for everyone? Okay, so this means that it is very, very simple to convince yourself that this vector, whatever it is, it lies on the plane of B and C. And according to this demonstration here, this is definitely true that I can write it as a combination of B and C. X, which is not known for us, times B, plus Y, which is not known to us, C. So if I can find a way to calculate X and Y, then I am done. Yes? That one equation is extremely simple to calculate. Yes? So if I dot product this by A, let us see what happens. If I dot product this equation, this is a number, it's floating, it goes out, A dot will affect this one. And then plus Y, A dot C. Do you agree with me? And then can you tell me what is the answer to the left-hand side?
A dot B.
A dot B, thank you. A dot B. Okay, and then what is the left-hand side now?
0.
It's 0. Yes? Because this is A dot, again A cross product, whatever. It's 0. So then it means that X, A dot B, so let me write A dot B here, plus A dot C, Y, is equal to 0. So this equation, finding this equation is extremely simple. So it means that X and Y should be numbers that they satisfy in this equation. But what was the formula? Do you remember? The formula is A cross B cross C is back cap. So it is B A dot C minus C A dot B. Yes? And that is exactly this number. This, I should be able to convince myself this is X. I should be able to convince myself this one is Y. And then actually you see that immediately this equation is satisfied exactly by those numbers. If instead of X I put A dot C, this becomes A dot B, A dot C. And instead of Y, if I put minus A dot B, this becomes minus A dot C, A dot B, which is 0. But finding the second equation is actually hard. Yes? I try to find second equation which will work, but it is not that straightforward. Of course, we will get a very elementary proof for this later, but I wanted to actually find another proof at this level, but it will take a long time. I think might be we can do it later if you are interested. But anyway, at least you know something here. And I want to give you two exercises and then we finalize this lesson. So one exercise is to prove, and I want to pause the video and give you a chance to do it yourself first. So I want to, as an example, And by the way, you need to memorize it in this way. So if this is A cross B cross C, this is 1. So you can write 1 cross 2 cross 3 is equal to, and then 1 dot 3 minus 3 times A1 dot 2. Okay, so don't worry about the names. It's because you want to memorize, but this is the way that you have to learn that. Okay, so exercise, let A, B, and C be arbitrary vectors. Arbitrary vectors. Prove that A cross B cross C plus B cross C cross A plus C cross A cross B is the zero vector. Yes, this is one exercise. Let me make sure that I have written it correctly. A, B, C, B, C, A, C, A, B. Yes, that's correct. This is one exercise I want to do. It's very simple, by the way. And there is also another nice exercise I want you to do. This is much better. So we want to show that if I have four vectors, I just write the formula. I want you to prove the formula for any four vectors. A cross B dot C cross D. I want you to show that this is equal to A dot C multiplied by B dot D minus A dot D multiplied by B dot C. Okay? But for the second one, does it make sense? What is the result of the left-hand side? Is it a number or a vector?
Number.
It's a number because that's a vector. A vector dot product is a number. But each one of these are numbers. So I'm multiplying numbers minus multiplying numbers. So the right-hand side is a number. The left-hand side is also a number. We want to show that this is not a coincidence. This is always the case. Okay, I will pause the video so that you can solve these two problems, and officially the lesson for the cross product at the level of geometry level. Yeah, because we want to talk about this analytically later. Any ideas how to do this one? This is very straightforward, I think. What should I do? I need to use the backup rule 3 times. Yes? So the first one, if the left-hand side becomes equal to, the backup rule here is B A dot C minus C A dot B. Yes? But for the second one, this is playing the role of the first vector, second vector, the third vector. Yes? So what can I write? The backup becomes C backup, yes, minus do you agree with the second one? Yes, and the third one, again, I use the same rule, but the first one is C, the second one is A. So backup becomes okay, and then what happens? They cancel pairwise. So this, the very last one is exactly equal to that. Why? Because A dot C is exactly equal to C dot A, so that's not a problem. And this one and that one are cancelled. This one and that one is cancelled. So the answer is 0, and that is exactly equal to the right hand side. Yes? But what is the second one? The proof. So let me start from the left hand side. this is a little bit tricky. If I ask you, is it a back-cab rule in this form, or is it a triple product? What is your answer? I hope that you agree that this is a triple product. If you consider this vector as vector A, then it becomes dot cross product of two more vectors. So that is exactly the triple product, yes? So, apparently there is no back-cab rule involved here. But this, you will see that how it is related. Can you tell me what should I do now?
Use the cyclic properties.
Cyclic property. So do you remember how to do that? Consider this as one vector and then move this to inside and bring D out. That is cyclic property. So this becomes what? D goes out. I want to make sure that you can do it. So D goes out, and then what will happen? Can you tell me what should I write? I want to test. You need to practice a little bit. So D goes out, and then what should I write in the pair of brackets?
First parenthesis and then A cross product B.
Yes, and then?
Cross product C.
Yes, everyone agrees? That is cyclic property. This is a slight deviation of the back-cab rule, because this A cross B is on the left, C is on the right, but I can put a negative sign and swap them. Yes, so this becomes negative D dot, and then I can write C cross A cross B. Yes? Okay, and now I can use the back-cab rule. So it becomes minus D dot. This back-cab for this one becomes A, C dot B, minus B, C dot A. Do you agree or not? Back-cab. Yes, that's correct. And then I can distribute this dot product inside. But now this is a number. It's a floating number, so it can float around. So this minus D will go and hit this vector. So this becomes what? This becomes minus D. I want you to understand what is the problem. So this is a number. If I multiply this inside, the number float around, and this will go and be multiplied here. So it becomes minus D dot A, and this number will be left for me. So it becomes minus D dot A, C dot B, and then when I multiply minus D here, this is exactly a floating number again, so this minus minus becomes positive, D dot B, and then C dot A is left. But this is exactly the right hand side, yes? So let us read it, A dot C B dot D, A dot C B dot D with positive sign, then I have A dot D, which is the same, and C dot B with negative sign. So that's exactly the right hand side. So, but this trick is actually nice to remember. So even if you have this combination, you can view it as a triple product and then use the cyclic property and then use the back-cab rule. Yes? So these two examples are actually good examples. And then let us finalize this lesson. Do you remember I talked about associativity of the cross product, and you will immediately realize that this is indeed not true all the time, yes? So here, A cross B, so it is on the board, so let me not write it. Oh, sorry. A dot, and if I ask you what is A cross B cross C, we also have it on the board. A cross B cross C, we did it here. Yes, that was the answer. Oh, with negative sign, sorry. So this becomes what? This becomes B C dot A minus A C dot B. Yes? And now you see that this one lives in the plane of B and A, but that one lives in the plane of B and C. And in general, the plane for B and A could be different from the plane for B and C. So it is clear that in general, this one is not equal to that one. And this means that even though this is meaningful to write an expression like this and this, but this is not equal to that, so it means cross product is not associative. Yes, so that is also one way to see this. Any questions? Okay, so everything that I wanted to talk about vectors from geometrical point of view is finalized at this stage. So I will try to work on the problems and publish them for you so that you can work on it. And then we will have 2 quizzes, I think, for this. But next week I will continue teaching to an analytic way of thinking about vectors, and then we will find the connection between geometry and algebra even more. Okay. Any questions? Thank you. And I will glue this video to the previous video and publish them. It takes a little bit of time, but I will do it during the weekend.